Hello, great minds. Welcome to today's class. Look at this radical expression here. Without the use of the calculator, we are asked to evaluate this. I released a challenge of this kind some days ago, and somebody in the comment section said I should bring more of expressions of this without the use of calculator, how to handle some radical equations with square roots. Now we have cube root radical and square root radical. So how do we compute this without the use of the calculator? And if you check this challenge carefully, this is a kind of unusual radical expression. Okay? Why? Because look at what we're having here inside and what we're having inside. So the question reads, evaluate the cube root of, under your cube root we have 1 plus the square root of minus 7. Then plus the cube root of 1 minus the square root of minus 7 again. So this minus 7 here under this square root radical is a kind of a big challenge. So how do we compute this? So if you're new here, this is Olamas TV. Do not forget to subscribe. Okay. So let's go into today's challenge and see what this gives us without the use of the calculator. Don't worry, we'll get the answer to this. We'll take a solution first. Okay. So what we do here now is to rewrite this expression we have inside this radical. So we know that the square root of minus 1 is equal to our iota. And so we just have to rewrite this and rewrite this. So rewriting this, we're going to have here the cube root of our 1 plus the square root of minus 1 times our 7. Okay, then plus the square root or cube root of our 1 minus the square root of minus 1 times 7. So separating this, we're going to end up having the cube root of our 1 here, then plus the square root of minus 1 times the square root of 7, then plus the cube root of our 1, then minus the square root of minus 1 times the square root of 7. Now, from this expression we have in here now, then we can bring in iota into the system. So this is going to give us the cube root of 1 plus iota root 7. Then we have this to also be the cube root of our 1 minus iota, then root 7. So this is the first thing we do here, right? Okay. Now with this, we can do a simple substitution to represent everything we have in here. So we're going to take a certain variable. I like using x because x is a king in the world of mathematics. So let's take x. So we can say here, let x be equal to everything we have in here. So let it be the cube root of our 1, then plus iota root 7, then plus the cube root of our 1 minus iota root 7. Easy. Right. Now, this expression we have in here, we can give it a name. So let's take this as equation. Let's take this as equation 1. This is equation 1. Now, from this expression we have here, equation 1, we're going to do another substitution again. So what is that substitution? Here, we want to represent the whole of this with another variable, represent the whole of this with another variable. Why are we doing that? Because if you look to the terms we have in here and the one we have in here, this is a conjugate of what we have here. So since this is a conjugate to this, what do? We do another substitution. So yeah, we're going to say here, let's take a, let a be equal to the cube root of the first expression here, which is 1 plus iota root 7. Okay, so if we have a to be equal to this is cube root. For us to eradicate this cube root, we have to take the cube of both sides. So yeah, we're going to have the cube of A will now be equal to, if we take the cube of this, it will go with the cube root here. So we're going to have here bracket 1 plus iota root 7. Let's close this bracket. Okay, good. So from here, let's give this equation star. Let's give this equation star. Then let's continue on this side and see what this gives us. On the other hand, let's replace this with B. So we say let B, so this time let's take B, let B be equal to the cube root of 1, then minus iota root 7. Again, we want to eliminate this cube root, and so we take the cube of both sides. So this is going to give us B to the power of 3 will now be equal to our bracket 1 minus iota root 7. Let's close it. And let's give this equation star, star, equation star, star. So we have equation star here, which is a to the power of 3 equal to this, and equation star, star, which is b to the power of 3 equal to what we have in here now. Good. What then will now be the value of our equation 1? So we can rewrite our equation 1 here now. So equation 1 could be written as what? Could be written as your x equal to a plus b, according to this first substitution here. So therefore, this now implies that our x is equal to our a plus our b. Let's give this equation 2. So this is equation 2, right? Good. Now, from equation 2, we want to cube this equation 2. Why are we taking the cube of both sides of equation 2? Look at what we have here. We have a cube root radical. Okay? So we have a cube root radical, and we have a cube root radical here. So for us to eliminate this, we want to cube both sides of this equation. And so this is going to give us x to the power of 3 will now be equal to Ra plus b r to the power of 3. So we can open this using the binomial expansion. Okay, so if we use the binomial expansion, this is going to give us here our a to the power of 3 plus the next coefficient is going to give us 3, then a to the power of 2, then b will come into the system plus the next one, the coefficient is also 3, then a will be to the power of 1 and b will be to the power of 2, and the next one, the coefficient is just 1, and then a will leave the system, then we now have b to the power of 3. I just use the Pascal diagram or triangle to get the coefficient of this. You remember that the power of every variable or every expression to 0, the value of it to 0 will give us 1, then to power of 1 will give us 1, 1, and to the power of 2 will give us 1, 2, 1, to the power of 3 will give us 1, 3, 3, 1. We all remember this. So look at the coefficient to the first term here. It is invisible 1. The coefficient to the second term is 3, which is this 3 here, and the coefficient to the third term is this. Then that of the fourth term is just 1. So this is where I got this coefficient from. Okay, now, so with this, let's look at this carefully. We can bring this and this together. So this is going to give us here our a to the power of 3 plus b to the power of 3, there plus what is common to this and this? We have 3ab is common. So we're going to have here 3ab. If we use 3ab to divide this, we are left with a. So we have here a there plus, if we use 3ab to divide this, we are left with b. Look at this expression we have here. So we are having our x to the power of 3 equal to this. Then let's look carefully here now and check out if we can get this from all the equations we have gotten so far. We have a to the power of 3. What is a to the power of 3? Look at it here. We have b to the power of 3. What is b to the power of 3? Look at it here. Equation star star. Then a times b. Do we have a times b? We've not gotten a times b, but we know that we have a and b. So we can do the multiplication out. Look at our a. We said a is equal to this, and b is equal to this. So we can do a simple multiplication of a times b to get the value for this. Then what is a plus b? If you check carefully, look at this equation here. There's somewhere where we already written out a plus b. Good. Our equation 2, we have a plus b, which is equivalent to x here. And so we've gotten all the parameters here except a times b. So let's go ahead and get the value for a times b. So from here, we now put here, we have a times b is equal to, what is our a? Look at our a here. So we have the cube root of our 1 plus iota square root of 7, then times our b. What is our b? Look at our b here, which is the cube root of our 1 minus iota root 7, right? Close bracket. Now, if we are to multiply this out, this is cube root, this is cube root radical. And so this is going to give us here the cube root of our bracket 1 plus iota root 7 close bracket 1 minus iota root 7 close bracket. Now, if you check again, this is a conjugate to this. And since this is a conjugate to this, what happened? We take the square of this minus the square of this second term or this very one here. And so if we do that, this is going to give us here this cube root of the square of 1 will still give us 1, but let's put it there, then minus bracket the square of our iota root 7 close bracket. I will learn something here. Do not forget that this is Online Maths TV. And if you don't subscribe, subscribe. By so doing, you are helping this platform to grow. This is Jakes and Emo. All right, so let's go again. We know the square of 1 will give us 1. So let's continue from here. This is going to give us the cube root of 1 minus bracket. Sorry, here is square. Put a square here. Now, this square will be distributed among the quantities we have here. And so we have iota to the power of 2. And here we're going to have square root of 7 to the power of 2. If we do that, let's check out something here. Remember, we said some other time that the square root of minus 1 is equal to iota. So if we decide to square both sides of this, square this, then what happened? This is going to give us minus 1 is equal to iota square. So iota square is equal to minus 1. Okay, so with this, we can put in minus 1 in place of this. So we have minus 1 there times this power will go with this. So we have here 7. Okay, how we learn this one here? Let's continue this side and see what this gives us a time. So we are still looking for our AB here. So we're going to have here A times our B. This is equal to, then what happened? Yeah, we're going to have the cube root. The cube root, is a cube root, please. All right. So the cube root of 1 plus our 7. So this is going to give us the cube root of 8. And what is the cube root of 8? That is 2, right? Good. So this is going to give us what? 2. Straightforward. So we now have A dot B is equal to what? 2. So we cannot come to our equation. Let's come to our expression, which is this very expression we have here now. X to the power of 3 equals to A to the power of 3 plus B to the power of 3 plus 3AB bracket A plus B, right? Good. So let's erase this and continue. So look at where we were before we decide to solve for our A dot B. So let's bring down the expression, which is S to the power of 3 equal to our A to the power of 3, then plus our B to the power of 3, then plus our 3AB, then bracket A plus our B. So substituting, what will this give us? Our A to the power of 3 plus B to the power of 3, we'll solve for that already, right? Good. Or, have we solved for that? Let's check it out. Okay, so let's just go ahead and solve for our A to the power of 3 plus B to the power of 3. So from our A, we said A, recall that A to the power of 3 is equal to our 1, then plus our iota root 7. b to the power of 3 is equals to 1 minus iota root 7. So if we add these two, which is a to the power of 3, then plus b to the power of 3, this is automatically 1 plus iota root 7, then plus 1 minus iota root 7. So plus iota root 7 minus iota root 7, these two will leave. So this is going to give us our 2. So our a to the power of 3 plus b to the power of 3 is just 2. Okay, so this is going to give us r2, then plus 3 times, let's put this in bracket. What is our AB? We just solve our AB to be 2 also. So we have here 2, right? Then bracket, what is our A plus B? From our equation, we have A plus B is equal to what? X. Sorry, equation 2. Look at equation 2 here. We said A plus B is equal to X. So we can replace A plus B with this X here. So this is going to give us our X, close bracket. Are we learning something? All right. So from here, let's use this to open up this. And so we're going to have this to be our 2 plus our 6x. Mind you, we have our s to the power of 3 down this place here. So move this to this side of the equation. So if we do that, we're going to have s to the power of 3 minus 6x minus 2 equal to 0. Now, this is a cubic equation. So I tried using the algebraic method to solve this cubic equation. Okay, it wasn't easy, but I was able to get the answer. All right. And again, another method you can use to solve this, you can use the Newton-Raphson method, but I don't like using the Newton-Raphson method. I'm not comfortable using it. Okay, it's a cool one, but I don't like using it. A better method of solving this is the graphical method. I have to solve this using the graphical method. Okay, so when I use the graphical method to solve this, I got 3 real roots from this expression here. Okay, so the graph to this expression or to this cubic equation is shown. All right, so from the graph seen so far, the 3 spots or the 3 points where this expression will give us 3 distinct real solution or real roots are x1 equal to minus 0.33987 dash. Then x2 we have minus 2.26180 Then x3 is equals to 2.60167. So this is the only positive integer among the 3 cubic roots to this expression. So evaluating this technical radical equation without the use of the calculator gives you these answers here. Okay, so this brings us to the end of this math class. I want to believe you must have learned something from this top radical equation. And I want you to drop a comment in the comment section. However simple the comment may be, just drop it in the comment section. It could be time J, it could be made an error in social step. It could be, would have done it like this. In other words, you have a better way of solving these radical expressions without the use of the calculator. Drop it in the comment section so that Online Maths TV can equally learn from you. Remember, Jakes loves you. And if you've not subscribed, subscribe to our channel. We are waiting for your subscription. When you subscribe, hit the subscribe button, the notification button rather, so that you can get notified whenever we drop an amazing video, because we are on a marathon race to be releasing at least 3 videos in a day within this period of time. See you in our next class, but till then, keep winning. Bye. Now.